Hey everybody, Bill Sky, the Linux guy, and today we're going to talk about file ownership, directory ownership, as well as security attributes. And I'm thinking about doing a video after this one on how to secure a directory and all of its files for a department. I'm going to think about doing that as a really kind of neat scenario as to how you manage the security of your file system. Now, in Linux, the file system is extremely secure. It's really difficult for hackers to get into your files if you've done it right. So that's what we're going to talk about today. So let's get right to it. Okay, so I have Alma Linux up here and running, and what I'm going to do is I'm going to go into activities and I'm going to go into the files application, and I'm going to go into my documents. I have a bunch of different things in my documents. Let's go into my assembler program or my assembler projects folder. And what I want to do is I want to actually look at the attributes of each one of these files. So I'm going to right click on this file and I'm going to select properties and I'm going to go to permissions. Now permissions is basically that. Who has permission to access the file? And I'm going to click on permissions, and I'm not really crazy about this owner me because me isn't my ID. My ID is Linux users, so I guess they're assuming that you understand who you are, but I don't know. I'm not crazy about that. So you've got three different things. You've got the owner, you've got a group, and you've got others. Now the owner is you. It's whoever's logged in and whoever owns that file, whoever's created the file, whoever's been given access to the file. And the same thing is with directories. It works the same way with directories. So that's the owner. The group is the group that's assigned to that file or to that directory. So if you remember when we talked about managing users and groups in a previous video, I showed you how to create a group, I showed you how to assign a user to a group, and we're going to be doing more of that. But also notice that group is Linux user, and that's my user ID. So that's why I don't like the owner saying me, because they look different, but they're the same. They're the same name, they're the same 8 or 10 characters. So that's the group. So remember, when I talked about managing users and groups, when you create a user, it automatically creates a group of that same name. So kind of neat. So there's the group, and others means everybody else. Anybody that remotely connects to your computer, anybody that logs into your computer, I mean anybody, what do they have access to? And as you can see right here, you've got the access specifiers. You've got read and write. Now if I drop this down, I can say read only, read and write. If I drop down for the group, I can say none, read only, read and write. And for everybody else, I have the same thing, none, read only, read and write. So those are the access specifiers for each of those categories of users. Now there's also another one down here called allow executing the file as a program. If I turn that on, then I can actually run it as a program. Why do they have that in Linux? Well, if you download a file, let's say you get an email, let's say you're not paying attention to your spam or whatever, and you open up an email and you download a file, that file might have noxious code in it, and by default it is not executable. Linux will not download it as executable. You have to specifically go in and make it executable. Now if you do that and you don't know who sent you the file, that's on you, right? You've got to know what you're doing. And that's a little bit extra of protection for you. And normally that's turned off unless it's an actual program. Now, all of these owners or all of these access owners or access users, these groups of users or these categories of users, every single file has those, even directories. I'm going to go up back to my documents. I'm going to right click on my directory and go to properties. And I'm going to go to permissions, and you can see them again. You can see that the owner, now there are different attributes, right? For the owner, I can create and delete files, access files, or list the files only. As a group, I can have no access to it, list files, access files, create and delete files. And then you can just see all these different things. Now also in this particular graphical user interface, I can change the permissions for the enclosed files, and I can specify exactly what I want. So that's kind of nice. However, if you have thousands of files to do this, and let's say you go into here and I want Jamie to have access to this one, I don't want her to have access to this one, I want Kathy to have access to this one as well as this one. There's a lot of complexity and right click on every one of those, especially if you have hundreds or thousands of files to do that with. And when you're dealing with a multi-user operating system, you definitely have that possibility that that's going to happen, especially if you're working at a company. If you're just working on your own computer in your house, you may not have that. Maybe you'll have 2 or 3 people having access to it. So maybe that's not that big of a deal. However, using the terminal, and I know you're going to hate this, but using the terminal, that makes it really, really easy. So let's go ahead and jump to the terminal, and let's take a look at categories of users using the terminal. Okay, so I'm going to go to Activities. I'm going to go to my terminal, and I'm going to be zooming in here. But before then, let's change directory to Documents. And what I'm going to do is I'm going to create a directory. So I'm going to say make directory, I don't know, let's call it Department 1. And if I do an ls, you can see it's kind of hard to see with the colors that they added there, but there's Department 1. Okay, so, but you don't see any attributes. So let's go ahead and type ls-al. There you go. So here's our department. Now I'm going to zoom in here and let's talk about what we're looking at here. So let's zoom in. And what you see here, these are all of the attributes of the files. Well, I shouldn't say all, but these are the majority of the attributes of the directory in this case. And the directory is Department 1. Now, who owns the directory? The very first ID, I guess it's the first, second, third column in the total, in the main attributes listing, is Linux user. That's my user ID. What group has access to that folder or that directory? Linux user. The second one is Linux user. And where are all the access specifiers? Those are these guys right here. Now we're going to talk about these access specifiers in a little while, but there is one that I want to talk to you about, and that's this D. That stands for directory. So that's a way to see that Department 1 is a directory because of this D here. Now you might say, well, I know Department 1 is a directory. Well, maybe your program doesn't know it's a directory. Maybe other people that are logged in accessing your files because you've given them access, maybe they don't know it's a directory. Maybe they're using a terminal that doesn't have color coding. So in this case, all directories are blue. Files look like they're white. In this case, install notes.txt. That looks like that's just a standard file. And then all executables are in green. You can see that shell script there, and you can see this one right here. So those are all green. Now that's great, but what if you're using a shell that doesn't have that? What if you're using a terminal that doesn't have that color encoding? So you need to know that this is a directory. Okay, and some other things about this. It shows the size of the file or the directory. It shows the date that it was created or last accessed, as well as the time. So those are those basic attributes. Now what I'm going to do is I'm going to move this up a little here. I'm going to leave it zoomed in so we can really take a look. I'm going to change directory into Department 1. Now if I do an ls-al, you can see that it's empty. However, let's take a look at these two things. There's the ... directory. That simply means go up one directory. So we were in Documents. If I say change directory ... that's going to take me back to Documents. So that goes up one. Now what happens? What happens if I change directory to dot? Because you can see this one here that says dot. What if I change directory to that? I'm going to change directory to dot. That just keeps me in the current directory. So dot is really not used in change directories very often unless you're doing something like there's another department and you're saying change directory to the current directory, some directory, which doesn't exist. But you might do it that way. So now that is especially useful if you have an executable program. Let me show you what I mean by that. I'm going to change directory back to the documents, and if you remember up here, I have an executable file, mount vmshare.sh. So I'm just going to execute that. I'm going to say mount vmshare.sh, and it says it can't find the command because it's looking in the path, and we're going to talk about the path in Linux in an upcoming video, but it's looking in the path. And since the current directory, documents, is not listed as an executable directory, it's not listed as a directory that has executable programs in it, it's not going to even look in the current directory. Now this is different than in Windows. Windows by default looks in the current directory first and then it looks at the path. But in Linux, that's not the case. Now you can change that, but that's not by default. So if I want to execute that, I say /, which means current directory. / means current directory. Mount it, and it runs it. Now, there's a problem in this script. It's not really a problem, but there's a problem in that script. So you get this little funny warning or error. Okay, so I was able to execute it. All right, so let me go ahead and... Okay, good. All right, so now let's go ahead and make sure where we are. Okay, so there's department 1. So I'm going to change directory to department 1. And that's what the dot and the dot are. Now let's go ahead and create some files. I'm going to say touch file1.txt, touch file2.txt, touch file3.txt. And you can see those 3 files now exist. There's no way you could have done that with a GUI that quickly. So, and I actually typed every one. If I had pressed the arrow up, it could have even been faster. So you can see those. And you can see that the owner is Linux user because that's the person that created it. You can see the group is Linux user because that's the group that Linux user belongs to. You can see each one of them is 0 size. That's okay. And you can see file 1, file 2, and file 3. Now, let's say if we want to assign those files to somebody else. Let's say if we want to give somebody else access to those files. So what I'm going to do is I'm going to create a user. I'm going to say sudo add user. Okay. So sudo add user, and I'm going to call this user1. Now let's give them a password. So I'm going to say sudo password user1. All right, great. Okay, now all I did was create a user. Now, when I created user1, it also created a group, user1. Let's say I want to assign all of these files to user1. Now, before we do that, I'm going to switch user to user1. And let's move this up a little bit so we can kind of get it in the middle of the screen. I'm going to log in. So now I'm logged into user1. How do I know that? Well, you can see user1 here in the prompt because I'm using bash. It displays that. All right, so I'm in there. Now I'm going to say ls-al. And I can see that these 3 files are actually owned by Linux user. So I'm going to try to edit it. So I'm going to say nano file1.txt. And it says file 1 is unwritable. I can put as much as I want in here. Nano is simply giving me a message, save the model file buffer. It says I can't write it, permission denied. So pretty neat. So let's go ahead and get out of Nano. Now let's go ahead and assign those 3 files to user1. So I'm going to exit out of that, and now I'm back in Linux user. I'm going to say sudo change owner user1 all files in the current directory that end with .txt. One single command, I'm able to change all the owners. Now, what does that mean? Well, change owner says I want to change the owner of all of the files in the current directory that end with .txt. I want to change the owner to 1, user1, and the group to user1. That's what that colon in there means. It means change it for both the user and the group. Now I could have said sudo change Linux user1, and that changes all of the owners back to Linux user, but the group accesses user1. So what does that mean? That means that I say that the owner is still a Linux user, but user1 can access them. Let's go ahead and say lsal, and let's take a look at that. So you can see that Linux user is the owner, but user1 group. So that means anybody inside of user1's group has access to those. Now, that's using the change owner, and that's specifying. Now, I don't actually have to use the group at the end of that change owner. I could say sudo change owner Linux user. Well, let's make it user1 again. And you can see now that all of those files are owned by user1 as well as accessible by the group user1. So I don't have to put the colon in there, but it's kind of a shortcut that if you want to specify both the user and the group. So let's go ahead and put that back. So I'm going to say sudo change own Linux user. Oh, I forgot the S instead of the C. There we go. Okay, let's say I just want to change the owner. So what I can do, or the group. Let's say we just want to change the group. So we did one where we changed both the user and the group. Then we did one where we changed just the user. Now let's just change the group. So I'm going to say sudo change grp Linux user. And so there you go. So we did the change owner, we did the change group. And you can do both, whatever combination, whatever works for you best. All right. So let's go ahead and put those back to user1. All right, great. So now I created those files, but I changed the owner to user1. I'm still logged in as Linux user, as you can see in the prompt. I'm going to try to edit these. And if you notice down here, VI or Vim is telling me it's read-only. That's because I don't have access, or I don't have write access to it. Okay, let's do something else here. I'm going to change directory to documents. Instead of having to go into the folder, I want to do it from the parent folder. So I'm going to say change owner. And I'm going to force and recurse. And I don't know if force is, I don't think force is there. I'm just going to say recurse. Linux user. Now what is this doing? This is going to change the owner of the department folder to Linux user as well as the group. Now it already is Linux user, but this way I don't have to go into the folder. I don't have to specify a file mask like *.txt. It's just going to do everything in that folder, and it's going to recurse down into the folder with this -r. Let's go ahead and press enter. Everything still looks the same at this level, but I'm going to change directory to department. And you can see it changed everything. Now if I had some additional directories, so I'm going to say make directory project 1, make directory project 2. I'm going to go into project 1. I'm going to touch file 1a.txt, touch file 2a.txt. I'm going to change directory to project 2, touch okay. You can see that I've got a directory inside of a directory that has two files, file 1a.txt, file 2a.txt. I'm going to go back to documents, and I'm going to change every single owner and group to user1 with a single command. And that's that change owner -r. This is the beauty of the terminal. So now department 1 is user1 owner user1 group. I'm going to change directory to department 1. You can see now every file, file 1, file 2, and file 3 is user1. Project 1 and project 2 directories are also user1. Let's go into project 2. And you can see even those are user1. So that is the absolute power of this command right here, of saying recurse into a directory. Wow, kind of cool. Now you can do that with change group, you can do that with change own, you can even do that with the chmod, which is something that we're going to do next. So let's go back to our documents folder, and let's clear the screen. Now let's talk about, now that we talked about owners and groups, let's talk about access specifiers. How do we actually change the access? Now to change the access, let's do a revisit here. We can see that user1 owns the department1 folder or directory. The user1 group has access to it. So let's go into it. Okay. Now you can see 3 files in there. I'm going to switch user to user1, and I'm going to put some data in file 1. Okay, now you could have used Nano, you could have used any editor you want. So I'm still logged in as user1. I'm going to cat file1.txt, and you can see that I put that data in there. That I put hello there, this file was edited by user1. So I'm going to exit out. I'm back into Linux user. You can see now that file 1 has a little bit larger of a size. Now also notice that the operating system or Vim, it also created a temporary file or a swap file. You can just ignore those. That'll actually go away, I believe. It may already be gone. Nope, it's still there. So that you can also delete that. I can say remove .**swap. And oh, I can't delete it because it was owned by user1. Oops. So good. I'm glad that happened. So let's talk about how can as another user access file 1. Well, I'm going to say cat file1.txt. Well, wait a minute. Why can Linux user view the contents of the file1.txt when it's owned by user1? That's where these access specifiers come in. So let's talk about these access specifiers. If you remember earlier in the video, I talked about this first one. It will be a D if it's a directory. Well, file1.txt is not a directory. So there's just a dash there. The next 3 characters, those are the access specifiers for the owner. R stands for read, W stands for write, and the third one is just a dash right now, but if it was executable, it would be an X. So that's the owner. So that means user1 can read and write that file. Can't execute it, which is fine because it's just a text file, but user1 can access it that way. Now the next 3 columns, those are for the group user1 in this case. It can read, but it cannot write, it cannot execute it because there's dashes in those positions. Those are positionally significant. The first character is read. If they don't have read access, it's a dash. The second character is write. If they don't have write access, it's a dash. And the third character is execute. If they don't have execute access, it's a dash. Otherwise, it's an X. So that's the user. The next 3 are everybody else. What else can everybody do to that file? Well, as you can see, everybody can read it. So I want to get rid of that. As user1, I don't want just anybody to see my files. So what I'm going to do is I'm going to switch user to user1. And let's just do file 1. So what I'm going to do is I'm going to say chmod. And I'm going to say for other, I want to remove read. That's one way of doing it. For other, the minus sign means remove, subtract, read access. Oh, and I think I did that wrong. So let's take a look. Oh, that's so silly. I forgot to tell it what file. So for other users, I want to remove read from file1.txt. So now if I ls-al, you can see that the owner has read, write, and read, write. The group has read only, and everybody else has no access. So let's say if that's working. So I'm going to exit out of user1. I'm back in Linux user. It shows the file name. Let's try to cat it. Permission denied. I cannot look inside of that file. So, and the reason was we said change the modifiers to allow an owner or to allow others. Oh, and I did that as user1. So change, switch user, user1. So we did this command. We said for all others, subtract read. Now what I can do is I can also do it for the group. So I can say, let's say I don't want even the group to have read access. So I'm going to say for group, subtract read, others subtract read. Now I don't have to do that because already others doesn't have read access. You can see that right here. Others doesn't have read access. But I can just, because I just want to show how you can do multiple at the same time. So now file 1, the only person that can access it is the owner. Now I can do that for every single file in that directory. Let's go back, and I'm going to do that using the chmod. I don't remember if it's a capital R or a minus R. And I want to do it for the entire directory. Oh, wow, that worked. Let's see what happens. Okay, so now department 1. We didn't do it. We did it on the files inside, but also notice that the department directory no longer now has read for either the group or for the others. Now, what's this X on a directory? How can a directory be executable? Well, if you want somebody to be able to go into the directory, you make it executable. I know that's a little bit confusing, but by making it executable, that means anybody can go into the directory. That doesn't mean they can access the files. It just means they can go into the directory. So to show you that, I'm going to exit out. So I'm back in Linux user. I'm going to try to go into department 1. Okay, so I can't even list them. However, I could go into it. Now, why can't I list them? Because I've been given no access to be able to list the files in that directory as Linux user. However, if I switch directory user 1 or switch user, no problem because user 1 owns them all. All right, pretty neat. Okay, now let's go ahead and do some other things. Let's go ahead and let's have user 1 say that let's let the Linux user group, anybody inside of the Linux user group, and we know Linux user is inside of the Linux user group, let's let anybody read those files. So let's say Linux user is the department manager and user 1 is the developer or the person working on the project. So what I'm going to do as user 1 is I'm going to say, let's go back up. I'm going to say chmod. We have to say change group first, right? So I'm going to say change group Linux user. And let's put a -r in front of there because I want to give everybody, I want to go down into all the subdirectories. Change group r Linux user, department 1. Let's see. Let's do this as sudo. Oh, I can't do it as sudo. So let's see. Yeah, the reason is because I think a super user did that. So let's exit out of that, and I'm going to do the same thing. So sudo change group -r department 1, and let's make it Linux user. Okay, so now I'm going to go switch user 1. Now I should have been able to do that as the user, but it might be because Linux user as super user did it. So, okay, so there's department 1. Notice department 1 is now in the Linux user group. So I'm going to change directory to department 1. Notice that every one of the files is the group assigned is Linux user, but remember, the group access specifiers are still screwed up. They still don't give any access. So if I try to cat, let's exit out and let's go into department 1. I'm going to go in as Linux user. I can't even see them because I don't have any access to them because of these access specifiers right here. Okay, so let's get out of that. Let's switch user to user 1. So what I'm going to do is I'm going to say chmod -r group plus read department 1. So what I just did was I said let all group users read everything in there. So let's say ls-al. You can now see that groups, in this case Linux user, has read access to department 1. Let's see if that's actually going to work. So I'm going to exit out. I'm back into Linux user. By the way, you might see me exiting and changing a lot. I'm always looking at this guy right here. What user am I logged in as? Okay, so let's lsal. There's department 1. I'm going to change directory to department 1. Look at that. I can now see it because Linux user has been given read access. I'm going to cat file1.txt. I can see the contents. I'm going to go into project 1. All right, I can see those. Awesome. So I've got read access to all of that stuff, but I can't write to it. So I'm going to say vim file1a.txt. It says read only. But if I try to do it, Vim even gives me a warning changing a read-only file. I can't do it. I can't write to it. So I'm going to say quit. All right. Now it's the same thing with others. You can change others. So let's say I wanted to give everybody read access. So since groups are already there, but let's do it. Let's do it in a single command. So I'm going to switch user to user 1. And I want everybody to have access to department 1 for read access. Now that was default, but we changed it. So let's go ahead and say chmod. User should have read. So let's make sure user has read. Group has read. And others have read. And let's make sure that we say -r for recurse. All right, so remember this right here. Others had no access. Others now have read access. And because that's a directory, it's execute. So change directory department 1. And notice that all others now have read access. So everybody has read access. Let's say we want to make the group read access or write access as well. So what I can do is I can say chmod group plus write. Let's make that recursive. Now you don't have to say recursive. Let's say we just want to have these files as write for the group. But project 1 and project 2, we don't want to make those for the file, for the group to have write access. So we're going to say group plus X, and we're not going to say -r, and we're just going to say /*. And now we can see that the group has write access to all of our text files. One thing I don't like is that the project, the directories also had write access. So what I'm going to do is I'm going to say change my group -write project *. And now you can see the project 1 and the project 2 directories do not have write access. Now what does that mean when I have a write access to a directory? Well, it means that I can delete the right directory, I can rename it, I can move it, I can write files inside of it. So you may not want to do that. Okay, so everybody in the group has write access. So I'm going to exit out. I'm back into Linux user. There's my file 1. Let's see if I can change that text. Oh, good. It's not telling me there's a problem. Awesome. And now I'm able to, as a member of the group Linux user, I'm able to edit that file. Now, we use the chmod command using user specifiers. And if you remember, user specifiers are these things. We want to remove write access for all groups for this specific set of files. We want to remove it, or we want to add it. We want to add write to all files. Or we want to do something like recurse, all users have read, all groups have read, everybody else has write. Well, that's a lot of text to type in. There's also another way that you can use chmod, and that's using numeric values. So let's talk about that. So before we do that, let's take a look at what these access specifiers are and what a numeric value means. Well, a numeric value is based on the power of 2, 3 digits. So it's either on or it's off. So the first one right here on the left, that's 2 to the 2 power. That would be a 4. So if you want to give everybody read access, you could say plus R, or you could say 4. You'll see what I mean about that in just a moment. The second one is 2 to the 1, which is a 2. So if you want to give everybody write access, you could use, say, chmod 2, which would give everybody, or which would give that owner write access. And then the third one right here, that's 2 to the 0, which would be a 1. So if you want to give everybody execute, you would say 1. Now, you can then combine those. Let's say we wanted to give everybody read, write, and execute. You would take the 4, which is the read, plus the 2, which is the write, plus the 1, which is the execute. You add those together, and that's a 7. So you're going to see what I mean about that in just a moment. So the number is never greater than 7 for each one. So that's for the first one. Then you specify a number for the second one. So let's say we wanted to give everybody read, write, execute, both the user and the group, to file1.txt, we would say 77. And then if we wanted to add others to that, we would say 777. So let me show you what I mean. So I'm going to say chmod 777 file1.txt. So that means change all of the file attributes for file1.txt to have read, write, execute, read, write, execute, read, write, execute. The first one is for user or owner, the second one is for group, and the third one is for everybody else. There we go. Look at that. So now this value right here is a 7 because r is equal to 2 to the 4, which is an 8. Or I'm sorry, it's 2 to the 2, which is a 4. The w is a 2 to the 1, which is a 2. That's 6. The x is a 2 to the 0, which is 1. That would be 7. Same here. 7, 7. Let's say I want to get rid of, I don't want to have anybody to have access. So I'm going to make that a 0. So now we can see instead of rwx right here, it's dash, dash, dash for everybody else. Let's say we want to remove execute. Well, that would be 660. And so now you can see execute is no longer there. Let's say we only want to give the owner read and write. And we only want to give the group read. Now remember, read is the furthest left character. That's 2 to the 2, which would be a 4. So we're going to change that to 4. So now the owner of the file has both read and write. The group has read and nothing else. And everybody else in the universe has no access. Whew. But that is a very common way of doing it. I do it that way all of the time. So I'm going to show you what I'll do here. I'm going to say chmod, and I want that to be 640, and I'm going to recurse. And it doesn't let me do it because, actually it doesn't let me do all of them because I would have to have super user access to do that. Let's go in and figure out why that is. So I'm going to change directory to department1. Oh, what did I just do? I just screwed up my, oh, look what I did. So I totally screwed up. I did not make the directory executable, which means I can't go in it. Even as the owner, I can't go in it. Oops, I totally screwed up. So what I'm going to do is I'm going to exit out. Now, Linux user is a super user, a sudoer. So what I'm going to do is I'm going to change mod. I'm going to say sudo change mod. And now I want it to be executable. I want this directory to be executable. So that's going to be, the owner's going to have read, write, and execute. So that's going to be a 7. The group should have read and execute. So that'll be a 4 plus a 1 is a 5. and everybody else should have 0. Oh, forgot the 1. Okay, so now let's take a look. Okay, so now the owner has read, write, and execute, and now in that directory, the group has read and execute, and nobody else can access it. All right, so let's switch user to user 1. I hope you're seeing the importance of understanding all of this. Okay, so let's change directory to department 1. Whew! Okay, I'm back into it. All right, great. So now you can see that it didn't actually change this. So let's go in and say change mod. And I believe I want it to be 640 dash recurse. And it wouldn't let me do that inside of project 1 because I don't believe, let's take a look. By doing that, I turned off execute for project 1. So it can be dangerous if you have subdirectories inside of your directory and you do this recurse thing with these attributes, that you change the attribute. I can't even go into project 1 anymore. And I'm not a sudo user, so I have to have Linux user do it for me. Okay, so I'm going to say change mod plus, let me see, user plus x group plus x project 1. Oh, got to say sudo. And let's do it for project 2. All right, there we go. Okay, so now we've got execute. So I'm going to change directory to project 1. So now I can go in it because I fixed that attribute. And we have read write. So you got to be careful with the directories, right? You cannot allow a directory itself to be modified in such a way where you can't get into it. So how do I fix that? How do I make it where I don't actually include the subdirectory inside of here? Well, let's take a look. So let's say we want to change all of the files, all of the attributes of the files inside of project 1, but we don't want to actually change project 1. So the project 1 subdirectory. So what I'm going to do is I'm going to say sudo, I'm going to say change mod. And actually, let's make it 600. And the way I'm going to do this, I'm going to say -r project 1 asterisk. So by specifying the /* at the end of the directory, it's just going to affect the contents of the directory. It is not going to actually affect the directory itself. So let's do the same with project 2. You can see now that the owner is the only one that has read write. That's because R is a 4, write is a 2. That's 4 plus 2 is 6. So a lot of little nuances in this, but once you get good at it, it's very, very productive. So I'm going to show you how you can do that. So I'm going to say, okay, I want to change everything to read and write for the owner only for department 1 /*. Now it says this is the problem. This is the problem we had earlier. It says I can't do that for project 1 because it changed the project 1 and the project 2 directories already. So you can see I can't even go into those any longer. So now I have to have the super user do it, or I have to request super user access for this particular part of the file system for project 1 and project 2. I can't even go into those anymore. I'm out of it. So I have to have the super user do it. So let's go ahead and change that to that. And now I've got my access back. All right. User access, owners, security attributes. Man, that was a lot. I really hope this helps out. I would not blame you if you wanted to start over and re-watch this video. It might be a good idea. I would really recommend you also, as you're watching the video, have your Linux up and running and play around with this. Literally go through everything I went through. Just watching the video is not going to do it for you unless you're a more experienced user. And if you're already a more experienced user, you probably don't need the video. So go through, take a look at it, try it yourself. It's actually a lot of fun. Make sure that you have super user access on one of your IDs so you can fix problems that you might create. But also, this is something you're going to be asked in a job interview possibly. And I'll tell you, every IT job that I have ever interviewed for asks questions like this. Even students that have been interviewed for IT jobs like this. Even development jobs, especially if it's going to be a Linux developer, if you're going to be doing development on a Linux operating system, they might ask you questions like this because this is basic Linux knowledge. So now, some of you may actually be watching this video and say, what about special attributes? Well, I'm going to do a separate video on special attributes because, I think we've done enough on this one. So I hope to see you at that next video.